Alright, so we can use an addition or subtraction formula to find exact values of things we couldn't do before, such as the tangent of 15 degrees. 15 degrees does not fit into one of our special right triangles, you know, the 30, 60, 90 or the 45, 45, 90. So what we do is we rewrite it as a difference of two well-known angles, 45 minus 30 degrees. Now we can use the subtraction formula for tangent, which I'll remind you of up here. So we're going to use that, and so the 45 will be the x and the 30 will be the y. So we've got the tangent of the first angle, 45 degrees, minus the tangent of the second angle, 30 degrees, over 1 plus tangent of 45 degrees times the tangent of 30 degrees. Okay? And now we know all of these values because these are all special angles. So the tangent of 45 degrees is right here. The x is square root of 2 over 2. The y is square root of 2 over 2. So you take the y divided by the x, and you get 1. So tangent of 45 is 1. So I have 1 minus the tangent of 30 degrees. 30 degrees is down here. The y is the square root of, is 1/2. So I've got 1/2 divided by the x, which is square root of 3 over 2. So I end up with 1 over the square root of 3. I can rationalize this now by multiplying top and bottom by square root of 3. So I get square root of 3 on top, and on bottom square root of 3 times square root of 3 is 3. So I've got 1 minus the square root of 3 over 3 on top, and on bottom I get 1 plus, again the tangent of 45 is 1, times the tangent of 30 is square root of 3 over 3. And now we'll simplify this expression. Since I've got 3 on the bottom of each of these, I will multiply the top of the big fraction and the bottom of the big fraction by 3. So I'll distribute, and what I get is 3 minus, the 3's cancel here, so I've got 3 minus the square root of 3 over 3 plus the square root of 3. Okay, so you know, we're usually not supposed to have a radical on the bottom, so to fix that we would multiply this fraction on top and bottom by the conjugate of this guy on bottom, and the conjugate of that is 3 minus the square root of 3. So I'll multiply top and bottom by that. So when I multiply the top out, 3 times 3 gives me 9. Then I've got negative 3 square roots of 3 and another negative 3 square roots of 3. So that's negative 6 square roots of 3. And then finally I've got negative square root of 3 times negative square root of 3, which is positive 3. On the bottom, they're conjugates, so there's not going to be a middle term. 3 times 3 is 9. Square root of 3 times negative square root of 3 is negative 3, and no more radical on the bottom. So on top, 9 plus 3 is 12, minus 6 square roots of 3 over 9 minus 3 is 6. Now on top, if I want to cancel the 6, I need to factor out something on top, so I'll factor the 6 out. And then the 6's cancel, and we end up with 2 minus the square root of 3 for the exact value of the tangent of 15 degrees. And that's how you would use an addition or subtraction formula. Here's another example where we can apply an addition or subtraction formula. This looks like the addition formula for sine, which says sine of x plus y equals sine of x times the cosine of y plus the sine of y times the cosine of x. And so in this case, the 20 is the x and the 25 is the y. So we're going to use this identity going this direction. So doing that, I can write this as sine of one angle plus another, and the two angles in this case are 20 and 25. And I know it's plus because this is a plus and these are pluses up here and here. So I end up with a sine of 45 degrees, which is the square root of 2 over 2. So even though I don't know the sine of 20 degrees or the cosine of 25 or any of these others up here, all of this ends up being the same thing as the sine of 45 degrees, which we do know.